So very good morning to all of you. So let us start the class. So before that one, thank you, Saksham. Before that one only you have given my AV is okay. Thank you. So it has become, this is the good sign that before I ask the question, he has given me the answer. Okay, fine. Thank you. So let us begin today's class. Meeting these people will be a problem. Okay. Yesterday we were discussing about the equality constraints and the algorithm for gradient method. These 6 steps I am explaining it. And here the new value of control variable, the control variable is u. So every iteration, the new value of control variable has to be determined using your old value plus the change in the value. So this delta u again depends on the negative because we are moving towards a negative direction. That's why it is negative alpha gradient of L, alpha gradient of L. So we are moving it. So this is alpha is a step size. So this gradient is adjusted by a step size which is known as positive scalar alpha. And how to select alpha? Again, there are some other optimization methods are available. Understood? So, however, those optimization methods will be not dealing it here. Selection of that alpha value. So again, there are optimization methods are there. Some algorithms are there to select appropriate value of your alpha. However, for your purpose, so I have explained that one. If alpha value is like a too small value, then it guarantees the convergence. However, it slows down the rate of convergence. Understood? So rate of convergence means, yesterday I have taken an example. So if you are asking, if keep on asking the direction for every 100 meters or 200 meters or half a kilometer to reach your destination, definitely you will reach the destination. But what is the time taken? So what is the time taken will become more. That means what? So it slows down the rate of convergence. Understood? Slows. That means you may take more time, means you are reaching that one in a slow way. So you are not reaching your destination at faster rate. So that is the meaning of slows down the rate of convergence. However, at the same time, on the other side, if you are selecting high value, that means if you are asking the directions for every 5 kilometers or 10 kilometers or 1 kilometer, 2 kilometers, etc., like that, long steps. So then what happens? That is high value. What happens? So you may end up crossing your destination sometimes. Again, after asking that one, you have to come back. Again, you are asking again. So oscillations may occur around your destination. However, you will reach your destination. So selecting a small value of alpha or high value of alpha also leads to a problem. So we have to select this alpha appropriately. There are some other algorithms or optimization methods are available to select this appropriate value of alpha. Okay. So till this point we have discussed in yesterday's class. So now today, so this is with respect to equality constraints on a control variable u, and we have written an algorithm steps, 6 steps we have written it till 5, step 5, it is okay, so no problem. However, step 6 was a critical step. Why it is critical step? Because choice of alpha is very, very important. You have to select that alpha appropriately. Is it clear? That's why it is a critical step. So till this point we have studied. Okay, now let us see. Now, while taking the optimization problem, we have seen that we have considered only the equality constraint. We have not considered any inequality constraint. So please recall, yesterday I told that one, we have considered only the equality constraints. We have not considered any inequality constraints. Again here, inequality constraints will be there on control variable and state variable. We have seen that one function f is a function of x comma u, isn't it? X comma u, we have taken it. So therefore, u is nothing but your control variable, x is your state variable. So inequality constraints will be there on control variable as well as state variable, that is dependent variable and independent variables. So first let us take inequality constraints on control variable. So control variable usually in any of the control system, general notation, so you will take it as a u, or some textbooks uses r also, control variable input as r. So let us take here control variable is represented by u. So what are the inequality constraint? You know that one. Inequality constraint means it will have either less than or equal to or greater than or equal to. However, here in this case, control variable will have the limits. This control variable will have the limits. So that means maximum limit and minimum limit. Understood? So that means what, this control variable should lie within the maximum value and minimum value. That means u should be, must be greater than or equal to u minimum and less than or equal to u max. This is your inequality constraint on control variable. See this control variable u. Understood? So this is your inequality constraint. So that is upper limit and lower limits are there. That you call that one as equation B. Now with this inequality, like inequality constraints, we'll see how to solve the given optimization problem. So now inequality constraints, that is control variable, means as already we have discussed, that PGI, generation. So generation can be controlled by varying the excitation or by opening the steam valve or closing the steam valve, etc. and all those things. We can control this generation usually at thermal plants. I am talking about. So example for this control variable is your generation at ith bus should lie between minimum value and maximum value. This is an example for your, this is a general value control variable. Control variable can be your voltage at PQ buses, so voltage at PV buses, or generation, a transformer tap settings, etc. I told. So here one example I have represented for your benefit. Okay. Now the correction, now this is the equation equation A. Already we have discussed this A, that is this comes in step 6. Step 6, the gradient algorithm, that is the steepest descent algorithm we have discussed, isn't it? So in that step 6 we have defined u nu is equal to u old plus delta u. Delta u again depends on alpha, isn't it, into the gradient value of L with negative sign. Clear? So for your convenient, so I have again represented the equation A already, which we have discussed. Now in this one, what happens? The addition of delta u to the old value of u causes your ui to exceed any one of the limits. It may exceed lower limit or upper limit. Understood? In such cases, what we should do? So here we are discussing about inequality constraint and control variables. So each time the control variable you are updating in each iteration. So you have to add this control variable till which point you have to update this value of u to u nu till your gradient reaches zero value in the negative steepest descent direction, negative gradient. Clear? Till that point we have to solve this problem. Okay. Hope you have understood this one. Adding a delta u to your old value of u may cause your new value of u to exceed. Here new value of u means it is nothing but ui. May cause to exceed the any one of the limits. It may cross the lower limit or the upper limit. If it violates the lower limit, what we should do to the control variable? If it violates the upper limit, the maximum value, what we should do with the control variable? So that is given by here. Now you see ui new. That means what is ui means? It is the control variable at ith bus. Control variable at ith bus or ith unit, ith plant, anything you can take it. So what is the new value of your control variable is equal to u volt plus delta u. Understood? So if this sum u plus delta I is greater than ui max, here it is, the limits has been specified for control variable. If this new value of u exceeds the maximum value, then your new ui value is fixed or clamped at your maximum value. Understood? Suppose if maximum value is 20, you assume it. If the new value of this u is more than 20, say 21, it is exceeding the maximum limit of 20. So what will be your u new value will be 20 only. You cannot take 21. So it is clamped at your maximum value if it is violating the upper limit. If this sum is, that is equation A, is violating the lower limit, that is if it is less than minimum value, then it is clamped. The ui new value will be clamped at ui minimum. Is it clear? This is how we have to clamp the values. We have discussed this one already in the load flow studies. Whenever it violates upper limit, the upper limit will be assigned to the new value. If it violates the lower limit value must be assigned to the new value. If it is within the limits, then you consider that one as your new value itself. That means what? When you can consider when u volt plus delta u is within the limits, minimum and maximum, then your ui new value will be equal to the same equation, A equation. Understood? So this is the meaning of your inequality constraint. How to treat this inequality constraints, which if it has been given. So I've taken only one control variable here. Like that, so many control variables will be there. I said PGA example, you may be having transformer tap settings, voltage magnitudes. So if it is voltages, if you are taking control variable, or this one only. So PGI new is equal to PGA max, PGA min, then PGA volt plus delta PGA. So like that, with respect to the corresponding variables, you can alter these equations. I think you don't have any confusion here. It is a simple. Already we have discussed this one in our load flow studies. After a control variable reaches any of the limits, that means if it reaches any of the limits, its components in the gradient should continue to be computed. See, this is important point. Once it reaches any of the limits, suppose if it has reached maximum limit, still you have to, so if it reaches the maximum limit, so the value will be clamped to the maximum value, but don't stop at that point. You have to continue to compute, so that the gradient should continually computed in later iterations, so that the variable value may be lying within the specified limits at later stage or later iterations. This is an important point you should remember. So once after clamping the values here, don't stop at that point. So you should continue your calculations or iterations, so that in the later iterations, the variables may lie within the specified limits. Is it clear? You should continue after clamping the values if it is violated the limits. So that is the important point, you should keep it in mind. Okay, obviously, whenever a constraints are there, you have to apply Kuntakar conditions, isn't it? This is what I said it. So this is the constraint. Apply the necessary conditions. What are the necessary conditions? Sufficient conditions. Yesterday I told what is the difference between necessary condition and sufficient conditions clearly by taking one example, non-technical example. I told you about necessary conditions and sufficient conditions. Now, necessary conditions for this inequality constraints are obtained by applying Kuntakar theorem or Kuntakar, those are known as Kuntakar conditions. Understood? So, these are the necessary condition for minimization of your Lagrangian under constraint B. Under constraint B. What is constraint B here? Inequality constraint. Clear? So, please remember that one here. So, these are the Kuntakar conditions. So, what is this one? So first order partial derivative of your Lagrangian with respect to ui is equal to 0, is equal to 0. That means this is nothing but your gradient. This is nothing but your gradient is equal to 0 if it lies, that is your control variable lies within the minimum and maximum values. Please remember this one. This is the first Kuntakar condition. That is, these are not sufficient conditions but necessary conditions. Okay, if it is within the limits, then your gradient, that is your first order partial derivative of your Lagrangian function with respect to the control variable is equal to 0 if it is within the limits. That is, gradient is equal to 0. Clear? If it violates the maximum value, if it, that is, if ui is equal to, if violates the maximum value, therefore ui is equal to, it is clamped at maximum value, maximum, so gradient will be negative. Gradient will be negative. That means dual same thing will be less than or equal to 0. Clear? Gradient will be negative. Suppose if it violates the minimum limit, then what will be the gradient? Can anyone tell? Based on these conditions, your gradient is equal to 0 if it is lying within the limits. No problem, not an issue. But it violates the maximum value, your new control variable will be clamped at maximum value and your gradient will be 0. That means less than or equal to 0 means it will be negative. If it violates the minimum value, then what will be the gradient? Can anyone tell? Yeah, Abhishek Sharma has given the answer. So others, please, it is a clear indication you are getting it here. So no need to do any research here. Saksham has given, so Abhishek Sharma has given positive. So that is right answer. Saksham also given gradient is greater than 0, partially right. Sushumna has given a negative. No, that is not right. Because he see here, whenever it violates maximum value, your control variable will be clamped at maximum value, ui max. So in such cases, already we have represented the gradient will be less than or equal to 0 means negative. If ui is equal to ui minimum, when you get this condition ui is equal to ui minimum, when it violates the minimum value, you will get a condition, if you, then minimum value will be clamped. So in such case, the gradient will be positive. That is nothing but here I am going to represent it is greater than or equal to 0. Clear? If ui is equal to ui minimum, when you will get this condition, when the control variable violates the minimum limit, then that minimum value will be assigned to your control variable. In such cases, your gradient will be positive, that is greater than or equal to 0. Clear? So these are the three Kuntakar conditions which are necessary conditions. As I told, so they may be asking in your any competitive examinations. So what are the Kuntakar conditions for an inequality constraint on a control variable? So you should write these equations, these three conditions. Understood? So all these three equations, I am representing it as 3, even though I have shown the bracket till this point. This C also includes this point. Why means because when you, so this is the equations. These are the 3 Kuntakar conditions for your inequality constraints on control variable. Please remember, we are discussing about the inequality constraints on control variable. Again, we are going to discuss the same inequality constraints on your state variable. Understood? Later stage. So this is the case we are dealing with. Now step 5 of the computational algorithm, that is gradient vector has to satisfy the optimality condition C. Understood? So I have given 6 steps, isn't it? In that one, step 5. So what is the step 5? Just I will show it to you. If you have copied it in your notebook or something, you have taken screenshot, anything. So here I will show you. This is 5. This gradient of Lagrangian function equals to 0 if it is within the prescribed tolerance, that is within the minimum has reached. Otherwise, go to this one, find out new value, etc., and all those things. This is your step 5. So this is the thing. Now in step 5, the computational algorithm, whatever we have discussed, the gradient vector has to satisfy the optimality condition. Any one optimality condition, it should satisfy. So if it is within the limits, gradient is 0. If it is reached maximum value, then gradient will be negative. If it is violated the minimum value, then the gradient will be positive. So it has to satisfy this optimality condition, step 5 in the algorithm, whatever we have discussed. Now this is what I said. Inequality constraints on dependent variables means what? Your state variables x. State variables are your dependent variables, isn't it? We have discussed about the control variable u, inequality constraints. Now if you have inequality constraints on dependent variable, that is your state variables. Same equation, there we have used control variable u, here we use the state variable x. Let us take x is greater than or equal to x minimum and less than or equal to x max. Usually if it is within the limits, we call it as a soft constraints. So that is the thing. So it is not, this soft constraints, it is, we are going to consider this one as a soft constraints. X is greater than or equal to minimum and less than or equal to x max. I will talk about this soft constraints within a few seconds or within a few minutes. Now example for your state variable will be your voltage. So this voltage magnitude must be greater than or equal to V minimum or less than or equal to V max for PQ buses. So for PQ buses, that is load buses, the voltages at all load buses should lie within the limits. Minimum value, maximum value. Usually what is the normal value of voltage to be maintained at load buses? What is the normal value of voltages to be maintained at load buses? Can anyone tell? Normal voltage at load buses. What is the value in per unit? In per unit. Can anyone tell? Okay, Saksham has given the answer. Others, what is the nominal or normal voltage that has to be maintained at the load buses? While discussing about load flow studies, I told we have discussed about these things. Saksham Sharma has given it is 1 per unit. 1 per unit. This is the nominal or normal voltage. However, there will be some tolerance value will be given. Tolerance value will be plus or minus 5%. Plus or minus 5% will be the tolerance value. So plus or minus 5% means it will be from 0.95 per unit to 1.05 per unit. So with this tolerance, you have a minimum of 0.95 and a maximum of 1.05 voltages. So at load buses, this will be 0.95 usually and maximum will be 1.05. But normal voltage will be 1 per unit for all load buses. Is it clear? So please keep it in mind. The inequality constraint on independent variable and dependent variables are different here. Okay, such inequality constraints can be conveniently handled by penalty function method. You see this one here. So this is the method we are using it. Understood? So if inequality constraints are existing on dependent variable, that is on state variables, then such type of problems can be conveniently handled by a method called penalty function method. What is meant by penalty function method means, so if a dependent variable or state variable violates any limit, if it violates x minimum, a penalty will be imposed. A penalty will be imposed. If it violates maximum value, still penalty will be imposed. Understood? Suppose you know that one, so you have to pay the examination fees. So they will give the time, okay, within so and so date you have to pay. Otherwise, what happens? You have another date, isn't it? Extended date. So, but in that extended date, you have to pay the fine, penalty. You have to pay the penalty, isn't it? So, if it violates that limits, you have to pay the penalty. But this penalty cannot be imposed indefinitely, isn't it? Suppose if you are not paying this fees, the examination fees has to be paid within 10th of November, and your examinations are going to commence from December 1st. Assume it. You have to pay November 10th. With example, I am taking it. You have to pay. Suppose for some reasons, you fail to pay this examination fees. Still, the university will give the extended date till 15th of December. Sorry, 15th of November or 20th of November. During this extended date, last date actually, what is the maximum limit? 10th November. But extended date is there till 20th November only. So within, if you are paying the fees between 11th and 20th of November, you have to pay penalty, isn't it? You have to pay penalty. But this penalty cannot be imposed indefinitely. What happens if you pay the examination fees in the December 20th? December 1st, your examinations are going to start. Will it be allowed? If you pay the examination fees in the month of December 20th? No, isn't it? Till certain limits, so this penalty will be imposed. This penalty cannot be imposed indefinitely. So this penalty also can be imposed till certain level, isn't it? So like that, so with that example, so if it violates any of the constraints, so a penalty will be imposed here. So penalty means what? What is the penalty means what? Suppose if your electricity bill is there, they may say that your due date will be within 15th November. If you won't pay the 15th within 15th November, what happens? A penalty will be imposed, isn't it? Penalty will be imposed depending on their interest rate, etc., and all those things. And how long they can impose this penalty? They cannot impose this penalty for too long. Suppose next month also you are not paid. What they will do? 2 months bill is pending now. What they will do immediately? They will come and remove they will disconnect the supply, isn't it? Still you are not paying it. So again they are having another step. Permanently they will disconnect your connection to your house, isn't it? This penalty is also permitted till some levels, till some time, not indefinitely. Clear? So therefore, let us see this, that is a penalty function method. Now the objective function is augmented by these penalties. So objective function is what? What is your objective function is? Minimize the total generating cost, isn't it? That is your objective function. So minimization of your total generating cost or total production cost. Production means here what you are producing? Generation. Clear it? So when you want to use that one, so this objective function, in addition to this objective function, your objective function is cost function. What is your penalty function? What is the unit of penalty function here? Whatever the examples I given, what is the unit of penalty function? Can anyone tell? What is the unit of penalty function? In which units we measure this penalty function? I given two examples for you, isn't it? Penalty will be imposed if you are violating the limits. So under which units this penalty function will be measured? Yeah, Sushumna has given, Saksham has given the same answer, rupees per time or rupees per hours, etc. that has been given, isn't it? Okay. So in generally, you have mentioned the time. So if you are mentioning the time, isn't it? It's okay. That is also okay. However, in general, we say that it is the amount. It is the amount, isn't it? In general, It is the amount. Penalty function will be in terms of rupees. Your examination fees may be say 500 rupees if you are paying within 10th November. Then penalty will be imposed of say 100 rupees if you are paying within 11th and 20th November. So here, what is the total cost is 100 rupees, 500 rupees, and penalty cost will be 100 rupees. So what is the total cost you are paying for the examination? 600 rupees. That means your actual amount plus your penalty function. You have to include it, isn't it? So here also in our economic operation, your objective function, that is cost function, plus your penalty function, we have to minimize it. Penalty function, we have to add it here. Is it clear? So therefore, that is the reason here the objective function is augmented by penalties for inequality constraint violation. If it violates, then only you have to augment that one with respect to your penalty. That means if you are paying beyond the last date, then only you have to pay the fine. Otherwise, no need to pay the fine. What is the amount you have paid? 500 rupees. So here, what is the objective function? Total cost. That is only the thing you have to minimize. Otherwise, what you have to minimize? You have to minimize your objective function, total cost, plus your penalty cost. You have to minimize it, isn't it? So when you have to consider this penalty cost, when it violates the constraints. That is the meaning of this one. Now this forces the solution to lie sufficiently close to the constraint limits when these limits are violated. Understood? So that means what? If the limits are violated, suppose if you have been asked to pay the examination fees within 10th November, if not, a penalty will be imposed till 20th November. Beyond 20th, you will not be permitted. So if time will be given, so this will force you to pay the examination fees which is close to your deadline time, isn't it? So that is the meaning of this one. If you are paying in December, then it is not close to your specified time or specified limit, isn't it? So even if you violate, so that violation should be close to your limits. Understood? Even if you are deviating, so that deviation must be close to your limits. Either it may be close to maximum limit or minimum limits. So that is the meaning of this one. If penalty is imposed, so that it will be close to your limits. The penalty method calls for augmentation of objective function so that new objective function becomes. This is what we have discussed. Now, whenever it violates, the objective function will change. So what will be the new objective function? Will be your old objective function plus the penalty function. So penalty function will come into picture only when it violates the limits. Otherwise, it will not come. No point in saying new objective function. So therefore, when penalty method calls for augmentation of the objective function, so we will have new objective function, so which is given by C dash is your new objective function. Understood? So C dash is equal to C of XU is your old objective function, is your old cost, isn't it? This is the objective function we have defined, plus the penalty function W, penalty function W. So how many dependent variables, violates the limits? Suppose if we are having 4 dependent variables, we are having 4 dependent variables. Out of 4 dependent variables, 2 dependent variables may violate the limits. Then this value will be, J will be 2, isn't it? So that means 2 variables are violating the limits. So first variable violated the limit. What is the penalty for that one? Isn't it? Second variable has violated the limit. So impose the penalty for second variable. So what is the total penalty? Penalty imposed on variable 1 plus penalty imposed on variable 2. Variable 3 and 4 are within the limits. No penalty involved on that one. Clear in this example? Penalties, 4 variables are there, out of which 2 variables have violated the limits. That means say variable x1 and x2 violated the limits. x3, x4 within the limits. So x1, a penalty to be imposed on variable x1, a penalty to be imposed on the variable x2, because these two variables violated the limits. So therefore, what is the total penalty? Penalty imposed on x1 plus penalty imposed on x2. So same way here, W is penalty, J means here J means x1 and x2 here. So that's why we have used the summation. We have used this summation mark with J indicates. J means number of violations, number of variables which violates the variables. Total 4 variables, 2 variables. So here J becomes 2. So here this becomes, when you expand this one, it becomes W1 plus W2. What is W1? Is the penalty imposed on variable 1. What is W2? Penalty imposed on variable 2. Clear? So this is your new objective function. With your old objective function, cost function, we are having penalty function with summation. So why we have to use summation? So I hope it is clear for you now. This is what I said, where the penalty cost, where penalty cost Wj is introduced for each violated inequality concept. That's why I said 4 variables, 2 variables violated. So x1, x2 are penalty will be imposed on these 2 variables, and some of the penalties imposed on these 2 variables will be your W1 plus W2. With that example, I've explained it. Next, a suitable penalty function is defined as, now this is the Wj is your penalty function. So this suitable penalty function can be defined as gamma j. In the algorithm, we have taken alpha, isn't it? We have taken alpha there. Do you remember? Selecting low value of alpha, what happens? Selecting high value of alpha, what happens? Isn't it? The same thing applicable here also. The same thing applicable here also. Wj is equal to gamma j into xj. J means with respect to constraint variable 1 or 2. Which variable has exceeded or violated the limit? That one we have to take. Gamma j into xj minus xj max whole square. This is the value we have defined it. The penalty function, we are defining it in this form, gamma j of xj minus xj max whole square. So when you have to consider this function when it violates the maximum limit, when xj violated x max, xj max. Understood? So when xj is less than xj minimum, that means when it violates the lower limit, then it is gamma j xj minus xj minimum whole square. Understood? If it violates minimum limit, what is xj is equal to xj minimum. Understood? When it violates maximum value, xj is equal to xj maximum. So gamma into the initial value minus the final value, xj minus xj max. Here xj minus xj minimum when it violates the lower limit. Clear? Whole square. Why we have to take whole square? What happens if we won't take whole square here? Because whatever penalty you are imposing, it should be positive value. You cannot say you have to pay minus 20 rupees as a penalty. Isn't it? It is not a penalty. It is a bonus if you are taking minus 20 rupees. Isn't it? So that's why in order to have positive penalty function, this is squared. This term will be squared. Whenever violation occurs, if it is maximum limit is violated, this is a penalty function. If it is minimum value is violated, this is the penalty function. Either this or this will be there, not both. Clear? So this is your penalty function. Please remember this one. You have to write and practice it, these things. Now, so obviously gamma j is a real positive number which controls degree of penalty and is called penalty factor. Here it is called as penalty factor. Gamma j is your penalty factor, which is a real positive number which controls the degree of penalty. Understood? So how to select this gamma j? The same explanation holds good that has been given for your alpha. Appropriate value of gamma j you have to select. Again, there are optimization methods which are available to select this gamma j. Now you see this graph. Let us take this one. So this is your penalty, and this is your penalty function Wj. This is your penalty function. So penalty function, so this is a variable x, we are taking it with respect to x, isn't it? This is your penalty on y-axis. So x minimum and x max are the values. Now you see between x minimum and x maximum, if it is lying, okay, you see this is solid curve. This is solid curve, this is solid curve. Now what happens? This curve comes like this, becomes 0, again it is like this, isn't it? Now between minimum and maximum value, what is the penalty? What is the penalty between the x minimum and x maximum? This is the penalty curve. This one from here to here, continuous, again here. This is your penalty curve. If it is between x minimum and x maximum, then what will be the penalty? 0. So there is no penalty if it is within the limits. So if it is lying within the limits, then we will call it as a rigid limits. That means from here to here, it is a rigid limits. It is called as rigid limits. Is it clear? It is called rigid limits if it is within the limits. If it is beyond the limits, then we will call it as a soft limit. If it is beyond the limit, we will call it as a soft limits. That's what I told. So therefore, if x variable, state variable violates the maximum value, so this is a penalty. What is your penalty if it violates x? So it starts increasing, penalty starts increasing, you see there, isn't it? So at x max it is 0. Suppose if it violates x max, so what happens to the penalty? It increases. At this instant, again this is the penalty. So it keeps on increasing penalty. But you see, we have stopped this penalty curve at this point. That means this is your 20th November. This is your 10th November. Isn't it? This is your 10th November. This is 20th November. Beyond 20th, you will not be permitted to pay. So this penalty also will be permitted till some optimal point only, not indefinitely it cannot be imposed. Okay, this is the soft limit. Again, if it is less than minimum value, it is less than minimum value, again you see penalty starts increasing. That means if you are deviating too much from this minimum value, so at this point, what is the penalty? This is the penalty. At this point, what is the penalty? This one. At this point, what is the penalty? This is the penalty. So if your deviation from this minimum value is large, then your penalty will increase. Here also, if your deviation from x max is large, more, your penalty also starts increasing it. So if you are close to minimum limits, then your penalty cost will be less. Suppose if your point is this one, red, so that means it is violating x minimum. But what is the penalty? This is the penalty. Clear? Suppose if it is violated x maximum at this point, what will be the penalty? This one is the penalty. Suppose if your violation limit is here, what will be the penalty here? So your penalty cost will be more if the deviation is too much. Understood? Increases. However, this cannot be imposed indefinitely. Only till certain level it will be permitted. You see this one? Only till this point we have shown it. So that's why these are known as your soft limits. If it is lying within the range, then it is rigid limits. Rigid means yes, you have to pay it within this time. No extension is allowed. So that is rigid. Now I am going to give rigid time for you. I am not going to give the soft limit to submit your assignment. I am going to give rigid time. Okay. So that's why it is called soft limit, means some flexibility will be there. Some flexibility will be there. That's why I defined it here. These are your soft constraints here. We are going to consider these dependent variables as soft constraints. That's why I represented in the bracket soft constraint. So I told you that I will be clarifying why that soft constraints are. So this is the reason why it is called soft constraints. Is it clear? That is, flexibility will be there. If penalty factor is chosen steeper, rigid values, it remains close to limits. Understood? That's what I have explained. But there will be a convergence problem. See here, convergence problem will be there. If you are choosing the penalty factor within the limits. That means if it lies within the closed limit, convergence problems will be there. If penalty factor is chosen a lower values, solution may be deviating from the limit. That means it is away from the limit. If it is lower value, the solution may be deviating from the limits. It will not converge. And if you are selecting the rigid values, it may close to the limits, it may lie close to the limits, but still convergence problem will be there. Understood? So you had to select this penalty factor gamma j appropriately. Again, some algorithms are there to select this gamma j that is not required at this juncture. Is it clear? So this is your penalty factor. So start with how to proceed, how to select without applying any algorithm. Start with lower value of gamma j and slowly increase it during the optimization process. So start with lower value of gamma j. So in each iteration, slowly increase the gamma value, like how we have done ui is equal to u volt plus delta u, isn't it? Like that, slowly increase it during your each iteration or optimization process. So once it becomes close to the limits, you stop at that point. So this is how you should deal it with inequality constraints on dependent variables, that is your state variables. Is it clear? So till this point, if you have any doubt. So all of you submit your assignments, first assignment, and you are aware that 9, 10, 11, 9th is my test, first test is there. So submit it within Saturday. This Saturday, coming Saturday, you have to submit your assignment in the Google Classroom only. So I'll be sharing a folder with you. So you can start submitting the assignments in the Google Classroom only. So please inform other students. Still 7 students have not joined my Google Classroom. If they have not joined, it is their problem. They cannot send it to my personal mail ID. It has been full. So it may bounce back. It will not be permitted if they have not joined yet. So please inform them to join immediately in the Google Classroom. So I'll be sharing the folder. So within this Saturday, that means 7th November, you have to submit your assignments. So rigid limit. This is known as rigid limit. So I am not giving any soft limit because there is no time here. Understood? Okay. State variables, dependent variables are same and it comes under control variable. State variables are different. Control variables are different. Please remember, state variable is your x. Understood? Is also called as dependent variable. Saksham. State variables are different. Controlled variables are different. Clear? So here state variables are your dependent variables, also called as dependent variables. Control variables is also called as independent variables. I have explained it in the last class. Okay, fine. Hope you understood that. Okay. Thank you one and all. Take care. Submit your assignment within Saturday. I'll be sharing the folder in Google Classroom. Thank you one and all. Take care. Bye.